therefore there are different kinds of irrigation efficiencies which are discussed in our next slides. The first one is efficiency of water conveyance. So it is the ratio of the water delivered into the fields from the outlet point of the channel to the water entering into the channel at its starting point. It may be represented by efficiency suffix C. C stands for water conveyance. It takes the conveyance or transit losses into consideration. Number 2 is efficiency of water application. It is the ratio of the quantity of water stored into the root zone of the crops to the quantity of water actually delivered into the field. It may be represented by efficiency suffix A. A stands for water application. So it may also be called an on-farm efficiency as it takes into consideration the water lost in the farm. Number 3 is efficiency of water storage. It is the ratio of the water stored in the root zone during irrigation to the water needed in the root zone prior to irrigation, that is, fill capacity existing moisture content. It may be represented as efficiency suffix small s. S represents water storage. Next, number 4 is efficiency of water use. It is the ratio of the water beneficially used, including leaching water, to the quantity of water delivered. It may be represented as efficiency U. U suffix U. U represents water use. Number 5 is uniformity coefficient or water distribution efficiency, and it is important. So just go through it. The effectiveness of irrigation may also be measured by its water distribution efficiency, which is denoted by efficiency suffix small d. D represents water distribution, which is defined below. So water distribution efficiency is equal to 1 minus average of the absolute values of deviations from the mean divided by mean depth of water stored during irrigation. The water distribution efficiency represents the extent to which the water has penetrated to a uniform depth throughout the field. So when the water has penetrated uniformly throughout the field, the deviation from the mean depth is 0 and water distribution efficiency is 1.0. So the next numerical is 1 cubic of water is pumped into a farm distribution system. 0.8 cubic is delivered to a turnout. 0.9 kilometer from the well. So you have to compute the conveyance efficiency. So as per the definition of conveyance efficiency, this is equal to output by input into 100. So the output was given as 0.8 and the input was given as 1.0. Multiplied by 100 is equal to 80%. 1.0 because of 1 cubic of water. The next numerical is the depths of penetrations along the length of a border strip at points 30 meters apart were probed. Probed means placed. So the observed values were 2.0, 1.9, 1.8, 1.6 and 1.5 meters. So compute the water distribution efficiency. We have to find out the water distribution efficiency. So the solution is the observed depths at 5 stations, which is already given, are 2.0, 1.9, 1.8, 1.6 and 1.5 meters respectively. So we have to find the mean depth first. Mean depth, that is capital D, is equal to 2.0 plus 1.9 plus 1.5 plus 1.6 plus 1.5 divided by 5. So the answer comes out to be 1.776 meters. So now the values of the deviations from the mean that we found are 2.0, which is the observed depth, minus the mean depth, which is 1.76. Similarly, observed depth 1.9 minus mean depth 1.76. minus 0.16, and minus 0.26. So, the absolute values of these deviations from the mean are again 0.24, 0.14, 0.04, 0.16, and 0.26. Now we have to find the average of these absolute values of deviations from the mean, which is small d. That is 0.24 plus 0.14 plus 0.04 plus 0.16 plus 0.26 divided by 5. By calculating, we found the answer is 0.168 meters. So now, the water distribution efficiency, whose formula is 1 minus small d by capital D, is equal to 1 minus mean. Mean we found out as 0.168 meters, and capital D is found out to be 1.76 meters. So by computing, we found the answer is 0.905. Hence, the water distribution efficiency is found to be 0.905. So this is your assignment for lecture number 11. So the question is, you have to name the principal kharif crops of your region. Region in the sense like in the place where you're staying right now, maybe your home place, hometown. So you have to name the principal kharif crops of your hometown and detail the agriculture and climatic requirements that are needed for sowing, growth, and harvesting of at least one of the principal crop. Then you have to give the normal requirement of seed, which will be needed per hectare, and the average yield per hectare of the crop. So you have to also suggest ways to increase the duty in an irrigation system. The last date of submission is on or before 12 September, that is Saturday. I will go through a video. Thank you.
Peterson here from Lendl. He's been working with NRCS for a few years now on a number of different projects. Came out to look at one of the most recent ones, which is a pipeline project with the idea of saving some water. We used to have a ditch running parallel with this road, and actually the ditch used to be right where the road is, and then the ditch at 90 and go across and then water this way. Well, now we just have one solid pipeline, a 21-inch and 24-inch pipe, and put these risers and eliminated a lot of ditch, and we're getting pretty good flow out of it. And we used to take, I don't know, probably 7 days to water this whole farm, and it's about 4 days now. And that's what's so nice about the system. If one side of the field's ahead of the other, you just close one down and hope for one, or either or, and it's just as simple as this. So it's pretty good to regulate. I guess what excites me the most about it is seeing the amount of water that we can save in a project like this. This is the first crop in after we put the pipeline in, and we dished it once, and then had him come and level it, and he put a nice finish on it, and then we just left it alone and come in here and planted it. It'll be fun to see how this irrigates with it being level, as opposed to still, the field we were just looking at that we're going to do a touch-up on later. One of the first projects I did with the NRCS was this pivot. They got me started. We did an Arnold loan on it, and Arnold helped me with the pipeline. We got it piped out here, and what this pivot's done to my farming operation is increased me just tremendously. I mean, the production of this hay, and you can see how productive this hay is, has been a great asset to this farm.
So this is Neil Clayton, and we come out to visit with Neil and talk about this ditch project he put in here. It's been a few years, hasn't it?
This will be the fourth year.
Fourth year. So you've got some experience with it.
Well, you have to love cement ditches. Obviously, the less time. The water savings, tremendous. We went from an 8-foot stream to a 10 to 12-foot stream. So basically, we cut from, on a 40-acre piece, roughly 32 hours down to 24 each irrigation, which is tremendous. Pretty simple, just close it, drop it down, makes pretty easy. You have the same type of gate in the middle, one gate to open, one gate to close. The water savings there, time irrigation's there. You know, obviously a lot better, easier to maintain, keep it clean. It doesn't take a lot of water. I mean, it really don't. The head pressure we get here is phenomenal. But this ditch, I mean, it's crazy.
It just gets you enough to get on.
You can push it. Which I'd rather water fast twice as once and soak it, you know, and not get your, have it just go into the subsurface.
So that's how you're getting your efficiencies on your plate. You're just pushing quicker.
The hay isn't staying just in Utah. It's going everywhere, worldwide. So yeah, I think it's really crucial that we take care of things and do them right.
You've got to be on the productive end of it. You've got to have all of this has got to be in the computer. You got to see where your margin.
Yeah,
and that's what my boys did that I never did. And he's different.
He's been amazing. I walked out and he showed me just his records.
Also, fertilizer he put on. How much seed he's got to plant to get back from the field. He's got records back of every stream of water he ever took and how long that seed took. And that's the winner. Yeah, that's how you make the work. If you are doing that, you're going back it up to a hole. This should make this a beautiful valley. It is not a valley. The fences are clean. The ditches are clean. It's just a nice valley.
I hope you enjoyed meeting Neil and Chad today. This is what makes my work so enjoyable, is to see them have some success at accomplishing their goals on their place.